so we are ready for 7.2, and this is going to be very similar to what we did in 7.1. Our learning target, we are going to graph and use exponential decay functions. In 7.1, we did exponential growth, and that shows a really fast growth, and this one is going to show the values decreasing because it's decay. So let's define what the exponential decay function looks like. So it looks exactly the same as far as the equation goes. Y equals AB to the x power, and remember A has to be greater than 0, excuse me, and in this case, since it's decay, B is a number between 0 and 1, and oftentimes that'll be a decimal number or a fraction number, but it'll be less than 1. And remember, B in this case would be the decay factor. And it has, if it's decreasing in value, that number has to be less than 1, but it can't be negative. Alright, so now we're going to graph, so we're going to look at the parent function again. So this is the parent function for exponential decay. So the very most basic one, it looks the same again, but this time our B value is between 0 and 1. And remember, this is a very, very basic graph because we don't know what the value of B is right now. We just want to get the idea of the shape of it. So it'll pass through 0, 1, and it'll pass through 1B, and it's going to look like the mirror image of the growth model. So our values are decreasing as x increases. And just like before, the x-axis is our asymptote. And remember, this is the line that the graph approaches more and more closely, and in this case does not cross. Okay. Our domain for all these exponential functions is all reals. And the range on this one, our y values are greater than 0. Can't have the equal sign on it though. Okay, so let's do an example of a graph. We're going to graph y equals -2, and then times 3/4 raised to the x power. So you'll notice that the B value is showing decay because this number is less than 1. So that's how you know it's decay. Now this negative sign is going to reflect it over the x-axis too. So reflect over x. And this B value is less than 1, so we know it's decay. Alright. Make our graph grid. And let's make an XY table. And we're going to plug in 0 and 1. Those are always good values. If I plug in 0, anything to the 0 power is 1, and then times -2 would give me -2. If I plug in 1, anything to the first power just stays itself. So I'd get -2, and I can write that over 1, times 3/4. So that'd give me negative 6/4. And I'm going to reduce that to negative 3/2, which is negative 1.5. Alright, so 0, negative 2, and 1, 1.5. Okay, so this is flipped over, and that's why the decay looks like this. And let's talk about, remember the domain is always all reals. But this time you'll notice that the y values are all less than 0. So y has to be less than 0 for the range. Alright, let's graph another one. Okay, just like with our growth models, if we have something added or subtracted at the end, it's going to move our asymptote. So now the x-asymptote is going to move up 1. So I like to go ahead and put this on my graph. And so instead of being the x-axis, it's going to be up 1. So let's make a dotted line here so we'll know that not to cross this asymptote. Alright, so let's make our xy table. We're going to plug in 0 and 1. We're going to get some decimal answers, but that's okay. If I plug in 0 here, I'm going to do it down here, I would get 2 times 3/5 raised to the negative 1 plus 1 on the outside here. Remember that when I raise a fraction to a negative exponent, I have to do the reciprocal. And then if I add 1 to this, I get approximately 13 over 3. And so then if I divide that out, it's about 4.3. Okay, if I plug in the number 1, I would get 3/5 to the 0 power, which is just 1. So 2 times 3/5 to the 0 plus 1 would be 2 times 1 plus 1, which is going to be 3. Alright, so let's graph these points. Alright, 0 and a little bit past 4. 1, 2, 3, 4. So right here. And then 1, 3. So these are real close together. And so this is going to be decay. So it's going to get closer and closer to this asymptote. I didn't draw that really well, but hopefully you get the idea. Decreasing in value, approaching this asymptote. Okay, so let's do domain, all reals. Range, all the y values are above 1, so y would be greater than 1. Alright, so we have one more example to do, and this is an application, so it's not a graph. And again, like we did that first on day 1, you don't have to write this example all the way out. But you can if you want to, but it says a new television costs $1,200. The value of the television decreases by 21% each year. Write an exponential decay model the television. All right. So remember when we had growth, we had to do 1 plus the interest rate, but since we have decay this time, we need to do 1 minus the interest rate. And that'll give us a number less than 1 in the parentheses. So in this example, the initial value of the TV, remember that's A, is 1200, and then we have to change the interest rate to decimal form. And then if we go ahead and do 1 minus 0.21, we get 0.79. So this would be our model. And then it wants us to answer this question: what is the value of the television after 2 years? Okay, so we'll just plug in 2 for our time. And we'll enter this in our calculator. And we're going to get $748.92. We would expect that value to decrease over time. All right, that's the end of 7.2.